Hello everyone, today we start Unit 5, which is polynomial functions, and our first focus is going to be on quadratic equations. Eventually we're going to build up to other degrees. So our goal today is to understand the general form of a quadratic equation and all of the different methods that can be used to solve quadratic equations. We already saw some of these throughout the year so far, but here are some, like 3 different ways to write out the general form of a quadratic equation. So the first is anytime we see a quadratic, we have to see an x squared. Otherwise, it's not going to be a quadratic. So the a, b, and c, those are all just the coefficients a and b, and then we have our constant c. So we have ax squared plus bx plus c. If that equals 0, that means we're getting ready to solve. If you see y equals or f of x equals, this means we're getting ready to graph. Now when we solve, the solutions are also called zeros of the polynomial. And it's really telling us the x-intercepts. So these are 3 different ways to say the same thing. Now if we take a look at just 3 cases where we graph quadratics, just going to make 3 sketches here. And this is kind of going back to complex. We can still get complex or imaginary solutions as well. So we'll say case 1. Now keep in mind our parabola can open up or it can open down. These 3 cases, I'm just going to draw where they open up. So the first case is, and again, a quadratic graphs a parabola, is my parabola, whether it opens up or down, is going to cross at most 2 times. So I would be able to say that we have 2 real solutions here. Abbreviate solutions this way. Or our parabola could just sit on the x-axis. So in this case, we say we have only 1 real solution, 1 real x-intercept. Or it's possible that our parabola sits completely above or completely below if it were to open down. So in this case, we would have 2 complex or imaginary solutions. In other words, we would have no real solutions. They would contain an I with it, so we would have 2 imaginary, we would say 2 complex solutions. All right, so next we're going to take a look at methods of solving quadratic equations. And again, we're looking at when our quadratic equation is written in general form. Now we've already had practice with factoring and then taking the square root. So today our focus is going to be on a process called completing the square, which I just abbreviate sometimes as CTS, completing the square, and then revisiting the quadratic formula. And then eventually we'll get into graphing over the next couple of days. All right, go ahead and pause the video if you still need to copy these down. We're going to take a look first at completing the square. Now, what this means to complete the square is we are completing a perfect square trinomial. And we just use the first 2 terms, the quadratic and the linear term, to help us. So let's say we started with an x squared plus 8x. I need to, and it's always going to be add, I need to add something onto this so that I can factor this into the same 2 factors. So the way we do this is we take half of the 8, which is 4, and then we square it, which is 16. So I'm going to add 16 onto it. This allows me to now factor, it's just factor into the same 2 binomials here, x and x, 4 and 4, plus and plus. or we could just write this as x plus 4 squared, which we're going to do throughout the process. So now this x squared plus 8x plus 16 is what we call a perfect square trinomial because it will always factor into some quantity squared. Let's go ahead and try this. X squared minus 10x. You figure out what we need to add on to this to make it a perfect square trinomial. Again, we take half, and if we look at ax squared plus bx plus c, we're going to take half of the b, whatever value that is, and then square it. So in this case, we take half of 10. We ignore the sign because we're always going to add it. Half of 10 is 5. 5 squared is 25. And then we could jump to just factoring this here as something squared. First is going to be an x, square root of 25, or half of 10 is going to be 5. My signs need to be the same, but in this case, they're both minus. All right, so our first few examples we will solve by completing the square. Now this only works if the leading coefficient is 1. If it isn't, we have to make it 1, which we're going to see in a few more examples. But right now the leading coefficient right here is 1, so that's a good thing. What I want to do is exactly how this looks. I want to keep the 40 over here. Now, eventually this could be your choice. I'm not saying completing the square is the only way to do this. Sometimes it is, sometimes it isn't. But not everything will factor. So when our equations, if we bring everything over to one side and set it equal to 0, it could factor. If it does, then that's the approach we want to take. If it doesn't factor, then completing the square will always work. It's just not always pretty. So what I want to do is complete the square for this side. So we have x squared minus 6x. I want to leave a little bit of space. Then I still have the 40, because whatever we add to this side, we have to add to the other side. So half of 6 is 3. 3 squared is 9. So I'm adding a 9 to each side. Next, I want to factor this into a quantity squared. So again, I start with x. And to figure out the other number, it's just the square root of 9 or half of 6. They're one and the same. Signs are always going to be the same. So in this case, it's going to be a minus. And then we get 49. Now we could use inverse operation. So I want to take the square root of each side. So I'm going to get x minus 3. But when I take the square root of 49, I need plus or minus, and that's going to give me 7. Now to solve for x, I get x is equal to 3 plus or minus 7. Well, this is essentially giving me two values, so I split the equations now. X is going to equal 3 minus 7, or x is going to equal 3 plus 7. So over here, x is going to equal a negative 4, or x is going to equal 10. And there are my solutions. Now, because these answers came out to be nice integers, this does tell us that we could have solved this by factoring. But like I said, sometimes we have a choice, other times we won't. And here's an example where this definitely won't factor. So what I want to do is start by taking the 1 to the other side. So again, our leading coefficient is 1, so that's good. I'm going to have x squared plus 4x, leave some space, and then I'll take the negative 1 to the other side. What am I going to add to each side? Half of 4 is 2. 2 squared is 4. So I add 4 to both sides. Next, I want to write this as a quantity squared. Always going to be an x. In this case, I'm going to have a plus. Square root of 4 is 2. And then we'll get a 3 over here. Again, we take the square root of both sides. So we'll get x plus 2 equals plus or minus square root of 3. That doesn't work out any nicer. And then to get x by itself, I just want to subtract 2, but I'm going to put that minus 2 in front. It's just going to look better. Negative 2 plus or minus radical 3. And that is our answer. Now here's a nice way to kind of check to make sure what we're doing here. And that's if you go to a graphing calculator on Desmos. So if I just were to type in our first equation, so if you take a look here, I just typed in our first equation, and if you notice here, our parabola crosses. This is a very long parabola here, so I'm not going to try to scroll out to see the whole thing. I'm curious to see where it crosses. which is right here at -4, 0, and at 10, 0. So that 10 and -4. So what we're doing is algebraically we are solving to see where the parabola is going across the x-axis. Okay, and here I just typed in the second one, x squared plus 4x plus 1. And if you see this is a decimal, so if we actually took -2 plus radical 3, we would get one of these values, and then -2 minus radical 3, we would get the second value. So you could definitely see these are irrational, but they're still real zeros. They're just irrational zeros. So even though we keep this as 1, this is really saying x is equal to -2 minus radical 3, and then x is equal to -2 plus radical 3. And we could just leave it just like this. All right, now in number 3, notice our leading coefficient is 3. We want it to be a 1. So in that case, to make it a 1, we want to divide every term by 3. Now we will work with fractions, unfortunately, and then this is the downside to completing the square. It's not always pleasant. So we're going to start with x squared plus 7/3 x plus 7/3 equals 0. I'm going to move the last 7/3 to the other side, leave a little bit of space. So now we need to take half of 7/3. So let's do some work off to the side. Half of 7/3, multiply straight across, is 7/6. Now I want to square 7/6. I'm going to get 49/36. So it's not pretty, but this is what we're going to add to both sides. 49/36. So now the left side is still going to factor into x. Signs are the same. That means they're both positive here, so I just put in a plus. And then I just take the square root of the 49/36, or half of 7/3, either way, 7/6 squared. And now I need to get common denominators, so that's going to be a 36. And 3 times 12 is 36. 7 times 12 is 84. Yes, we're doing this without a calculator. Now, if you wanted to figure this out without a calculator, just do 84 minus 49 and just make that answer negative. See, I have to borrow here. So we have 14 minus 9 is going to give us 5. 7 minus 4 will give us 3. So we're getting -35/36. Now we take the square root of both sides. So we're going to get x plus 7/6 is going to equal plus or minus. Now what I would do in this case is just take the square root of the top number over the square root of the bottom number. I'm also going to subtract the 7/6. I want to write that first. So we're getting -7/6 plus or minus. Now the square root of -35, just an I comes out. We don't want to leave negatives underneath. So we get I radical 35. Square root of 36 is just 6. And then there's our answer. Now if we were to graph this, because we got an imaginary term here, and this whole answer is a complex number, all this means is our parabola is going to open up because our leading coefficient was positive, but it's never going to cross the x-axis. The entire parabola sits above the x-axis. All right, so as you saw throughout this problem, the fractions we had to work with weren't the nicest. So we're going to do the same problem again, but now we're going to use a quadratic formula. The quadratic formula, again, it works out every single time. You don't have to worry about completing the square. It comes from completing the square. So it's like they rearranged the formula, ax squared plus bx plus c. Somebody already completed the square here and solved for x to give us the quadratic formula. So here it is. Quadratic formula is x is equal to one big fraction. In the top, it's the opposite of b, plus or minus square root of b squared minus 4ac, and in our denominator we get a 2a. So a, b, and c come from our equation. So right here, 3x squared plus 7x plus 7, a is 3, b is this 7 right here, and then c is the other 7. So as I go to use the quadratic formula, x is going to equal the opposite of b, so we get -7 plus or minus Square root. Now, b squared will always come out to be positive, so 7 squared is 49 minus 4, and then a times c is 21 all over 2 times a, so that's 2 times 3, which is 6. Now we have nothing but numbers to work with. So I still leave the negative 7 plus or minus. This will give me 49 minus 84. Didn't we do that in the other problem? We had negative 84 plus 49 all over 6. So this gives us negative 7 plus or minus. So this is where that negative 35 will show up again, all over 6. And we could leave this as negative 7. We still want to take the I out. Plus or minus I radical 35 over 6. It was a little bit nicer to work with using the quadratic formula. All right, so let's just try one more. Actually, I have 2 more examples, rather. Right, so again, I have the formula, quadratic formula, written off to the side here. 3x squared plus x minus 2 is equal to 0. So that means a is 3, b is 1, and c is negative 2. So we're going to start with x is equal, make one big fraction here, the opposite of b, so negative 1, plus or minus the square root of b squared, so that's 1, minus 4, a times c will give us a negative 6. 2 times a will give us 6. I want to calculate what's underneath the square root first, so we get negative 1 plus or minus. Now we're really doing 1 minus 4 times negative 6, which becomes 1 plus 24. So we get the square root of 25 all over 6. Now because 25 is a perfect square, that tells us we go further. We could take the square root of that. Now when the radicals go away, we want to continue with this. So this becomes negative 1 plus 5 over 6. We split this into 2, where x equals negative 1 minus 5 over 6. And we still continue. So we're going to get 4 6, which is 2/3. And then over here, we're going to get negative 6 over 6, which is negative 1. So our 2 solutions are negative 1 and then 2/3. So again, if we were to graph this quadratic function, our parabola will cross the x-axis at these 2 values. Now, because they came out to a nice integer value and a nice rational number, that tells us we could have solved this by factoring. But I told you before, quadratic formula and completing the square will always work. Quadratic formula is really my preference if I can't tell that it's going to factor right away over completing the square. So let's just try one more. Again, here's the quadratic formula. Now, just like with factoring, we want to get everything to one side. So we'll have x squared plus 4x minus 1 equals 0. This one definitely won't factor. So a is 1, b is 4, and c is negative 1. So x is going to equal opposite of b, so negative 1 plus or minus, negative 4. Plus or minus the square root. B squared will give us 16 minus 4. A times c will give us a negative 1. And then over 2 times a, that's 2 times 1, which is 2. Again, let's take care of what's underneath our square root. So we'll get negative 4 plus or minus. This becomes a 16 plus 4. So we'll get a 20 over 2. Definitely not an imaginary answer or a complex answer, but we still need to simplify radical 20. So if you guys recall, radical 20 becomes radical 4 times 5. Square root of 4 comes out as a 2. So we get negative 4 plus or minus 2 radical 5 over 2. Now the 4, 2, and 2, yes, can simplify. We'll divide everything by 2, so we'll get a negative 2 plus or minus a 1 radical 5 all over 1. So this is our answer. And just to keep in mind, these are technically 2 different answers, a negative 2 plus radical 5 and then a negative 2 minus radical 5. So we're going to continue with these types of problems tomorrow. So off of the quadratic equations review, I just want you guys doing 1 through 9. So just to show you what you'd have to do here, 1 just kind of goes back to our notes. 2 through 5 solve by completing the square, and 6 through 9 solve using the quadratic formula. Eventually what we'll get down into is where you choose the method that you wish to try to solve this. So I'll have this posted as a separate PDF. Let me know if you guys have any questions.